Please welcome to the stage President of TA Grimm and Associates, Todd Grimm.
Oh, come on, you can give me something, can't you? So few bodies to work with. I'm going to feel bad for calling you out and having you applaud for things. Todd Grimm, as the voiceover said, I want to welcome you. Well, first off, good morning, and I want to welcome you to day 3 of Rapid Plus TCT. It's been an awesome week so far. I'm looking forward to a great day on this final day. Now, also, well, show of hands, who attended the industry celebration last night? Quite a few of you. I want to thank you very much. The energy in the room and the number of bodies packed into it, enjoying each other's company and networking and making those connections was just phenomenal. So thank you for making that a phenomenal event. And SME, thank you very much for sponsoring that. So as the voiceover said, I'm Todd Grimm, and my role here is in the capacity of event advisor. And on stage, I'm your tour guide to try to assist you with some of the highlights of the program for the day and also the show floor, because there is so much going on. You've got to use your time wisely. So my goal is to highlight a few things that maybe you'll jot down and say, that's something I would have missed. So I'm going to try to do that both on the program and on the expo floor. It's been a wonderful week. I'm looking for it to continue, and I just advise you, keep your foot on the throttle. Don't treat this as the last day and I'm just going to take it easy. Keep learning, keep gathering information, because it's out there for the applications, the technologies, the solutions that support those applications. And it's up to us to use this time wisely to gather that information. Now on the program, please bring up the slide. If you haven't already seen it and you haven't already done it, you want to download the SME Plus app, because everything about the day's agenda, from conference programming to show floor presentations to exhibitors, is in that app. So get that on your device, and very importantly for our coming panel discussion, please the next slide. On the home screen of the app, at the bottom, there's a tile that says Live Interactions. We will be taking questions digitally rather than orally through microphones. So if you have a question of our panelists, live interactions, and type in your question. The panel, which is probably the reason that you're here, starts at 8:30, and we're going to be talking about the state of additive manufacturing with 4 wonderful panelists, each one I can call a friend. So that'll be a very good event. We also here in the main theater have a 12:30 award ceremony. I'd encourage you to join if you can carve out the time, because we're going to be recognizing the winner of the Pitch Fest competition, which happened on Tuesday. So those were Shark Tank-like presentations, judged, and the judging results will be announced on this stage. And then also the Startup Challenge, which was a submission-based competition for the best startup ideas and innovation. So those will be announced at 12:30. Other things that we have is a busy show floor. And I'm a Rapid guy. I'm not on the WCX side. So our show floor is going to be busy. I just don't have the highlights for your show floor if you're WCX. But we've got the Discovery Zone open on the show floor, which quite honestly, if you haven't stopped into that, I was amazed at the strong solutions from these smaller companies here for the first time at Rapid Plus TCT. Visit that. SME is encouraging the participation in the mission critical Workforce 2030 area. That's where you've got the ability to get live assessment and talk to think tank kind of gurus to assist you with your assessment, but to get the conversation going on skills gap and having the people to do the jobs that we need. We also have the Tech Hub. Those are presentations by the companies that are on the expo floor. Today it's 2 because of a shorter day, and that is HP will be speaking, and then also a company called Interspectral, which is about 3D data visualization and other data manipulation tools. Great opportunity if you're more of an introvert and don't want to interface at the booth. You can sit in the Tech Hub, hear what they have to say, and then decide if you want to further engage. What else do we have? Closing social. So the Rapid Plus TCT show floor, it runs from 10 to 3. And from 2 to 3, there's a closing social where there'll be snacks and beverages and a final opportunity for you to engage with others, to make those connections and make those friends, which is something I encourage you to do. I've been coming to this event since 1995 without a missed year, and that's because of the people. If I didn't have those strong connections, I would not have given so much of my time over the years to be here, but also because they helped me. On the things you see on the show floor, they helped me with 3 or 4 of them because I totally missed them. I walked right by the booths. It didn't look like something I was interested in, walked by. Somebody, a friend, a peer tells me, have you seen this company? Here's what they're doing. Got to mark it down. Build those connections. On the show floor, let's start with materials. I'm going to highlight just 2 companies, although there were a ton of new materials introduced or discussed here at Rapid Plus TCT. But the 2 I want to call out, one is because they launched here at the event, and it's also a world's first, and that's a true silicone using a photopolymerization process. The company is Axtra 3D. The material's from, I can't remember the company name, but they exclusively have the rights to use this material, but it is silicone in its truest, purest form that's grown additively through their process that combines DLP and SLA. What's interesting, and kind of the theme of this year's event, if you talk to Axtra, they are very unique in what they are doing with additive manufacturing technology, but they quickly poo-poo that and want to talk about the applications. Can we solve your problems? So the technology is not the highlight. The what it can do for you is, and that's been a theme that I've seen throughout this event that I truly celebrate. Also on materials, this company is new. Its materials currently are not new. If you're familiar with Jabil, they're a massive contract manufacturer. They used to have a materials R&D arm for additive manufacturing materials. Well, I said used to because a new company spun up to take all those assets called Lumis Polymers. They're in the discovery zone. They've taken the assets and the materials, and they're going to continue the customization and pushing powdered material boundaries for additive manufacturing. One material that really catches my eye is called PK 5500. It's a polyketone with a very high elastic limit. Great for those applications where you need some damage tolerance, because it can be pushed out to 10%, the elastic limit versus a 2%. So that gives you that area where we can rebound from an overloading condition. Then I'll move on to post-processing. A tough category to make interesting in a presentation like this. But they're essential. They're fundamental to us getting the job done right and getting it done efficiently and getting it done consistently. The first one is Dimension, 3 new products. They announced the PowerShot X. This combines their automated, pre-programmed end-to-end capabilities for cleaning powdered parts, powder-based parts, and also surfacing them. Used to be, well, it still is, 2 different machines. They've combined that into one so you can run both operations. DM60 reservoir. How boring can that be? Well, they're solving a problem. Big time in automotive, lots of black parts. Before DM60 reservoir, after one single cycle, flush all that wastewater out and lots of dye. They're recapturing that dye, reusing the wastewater for up to 12 cycles with the same batch. And then finally, new color families. First one is tactical, so if you happen to be in defense related, they got a full palette of camouflage-ish colors to dye your parts. But the one that caught my eye is for automotive. Announced a new line which is introducing UV stability to the standards expected by the automotive industry. So a black part stays black even though it's under the sun, shining through your windshield. And Solucon with the AT1500. It is a depowdering system for metal parts, for massive metal parts. The load can take up to 2,100 kilograms and parts up to 1.5 meters. Meant to be plug and play, using ultrasonic excitation to get rid of that powder. So drop your part in, don't worry about programmatically, they'll take care of it. And they claim that it is plug and play. Uncrate it, plug it in, put it in place, and you're off and running. Test and evaluation. This was an interesting category. So you probably are unaware of them because they're first time last year. Phase 3D uses fringe projection for live data capture in powder bed fusion processes, where they're projecting the fringe using that to probably a photogrammetric process, but they're capturing the data not only as a visual image, or not even a visual image, of the layer, they're capturing a height map, which allows you to, during the process or after the build, go in and interrogate dimensionally that part, and it also identifies anomalies to flag you that, hey, you might have a problem with your build. Well, the new thing for them is they're now supporting cold spray. So if you are using metal additive manufacturing with the cold spray process, they're now taking this fringe projector, putting on the end of the robotic arm that has the head on it, and live capturing the data from the cold spray, looking for defects, looking for anomalies. And then finally, this is another one that a friend said, have you taken a look at it? Because I walked by it, I thought it was a laser engraver. This is also in the Discovery Zone, a company called Labs Cubed. Automated tensile testing. So even an idiot like me can do my own tensile testing. You load up your dog bones, tell them how many dog bones is in the tray, automatically picks it, measures it to make sure the thickness is within tolerance for the testing, does the poll, captures the data, reports it back out. So load them up, hit the button, walk away, and you've got your tensile data on your dog bones. Then let's move to, what do I want to move to? Let's move to electronics and wrap up with electronics. Company with I'm going to say the worst acronym across all of the Rapid Plus TCT show. The company is called Advanced Printed Electronic Solutions. When you boil that down, what does it spell? APES. It's pronounced APES. I embarrassed myself by saying, what is APES up to? I was misled. They've got misled by the information I had because I tried to connect the dots and it was incorrect. They have a new solution called the Matrix 6D for printed electronics. Well, it's much more than that. It's actually a scalable manufacturing solution that can also handle printed electronics. They're basically a design configurator, system integrator, taking the print heads for electronic printing or FFF or others, and using robotic motion, they're calling it software-enabled manufacturing, to transport between stations. So print some electronics, go and do some FFF to create the rest of the body of the part, come back, do some printed electronics, and then transport it on. Starts off with a unit about yay big. They can supply bigger units, and then you can stack all those units and have this software-enabled manufacturing. Another one that a friend pointed out to me, I was going to walk right by because I'm really not a printed electronics guy, is ChemCubed. They're a materials company, but they're doing printed electronics, and I'm glad I stopped by. A unit for less than $200,000 that just came out. They can print you circuits or PCBs. I don't know, I think I saw 50 on the sheet in about 5 minutes using inkjet technology. The kicker on that is what they deliver because of their chemical expertise. When you're done, they're delivering particle-free copper and silver traces. So conductivity is at its maximum. So quick solution for prototyping, but also scalable for production, and it can print on both flexible and rigid membranes. Now, right there, nothing in that was the, gee, wow, I'm going to raise the roof, go home and tell everyone what I saw. It's all practical solutions. Even though you may walk by them, or if you walk by them, you won't know them, but what they're doing is important things to allow us to advance additive manufacturing in the applications we intend to use. So that's something that I celebrate. Some will write about this event and say, it's dying. There was nothing new. There was nothing interesting. That's not the point. We've reached a level of maturity. We're certainly not fully mature yet, but we've reached a level of maturity where now we're making that practical advance to solve your front end, your back end, your printing challenges. And I celebrate that, and I think all of us should celebrate that. And as you go through the day, in the conference sessions, the presentations, or on the show floor, put that in the back of your mind. Don't be looking for the gee whiz. Be looking for the solution that can help you when you go back to the office next week or next month. So what I'd like to do, because there's countless hours put into this event, by volunteers, by speakers, by moderators, by the staff of SME, by the staff of SAE for the WCX, by America Makes, which is here in collaboration with the event. Tons of effort, tons of time to make this happen. Would you please indulge me, and I want it to be strong, giving all of those that have contributed to this event a strong, strong round of applause, please. It's been my pleasure doing this for the last 3 days. I hope it's been beneficial to you this morning, and if you attended others on the previous days. And I'm just going to simply close by wishing you have a great day and find some great solutions. Thank you so much.
Additive manufacturing is impacting everything. Everything we touch, everything we see, hear, drive, fly, light, build up, tear down, and build again. Every part of our lives. Industrial 3D printing and additive manufacturing. As powerful as it is flexible. As sustainable as it is customizable. And for 35 years, SME has gathered the greatest and boldest minds, the titans of industrial 3D printing and additive manufacturing, and built a strategically located premier event that's one of a kind, Rapid Plus TCT. This is where the additive manufacturing community of leaders, emerging startups, and vital suppliers come to showcase innovations, insights, and solutions, and discover new ways for the world to travel safer, live longer, learn better, and advance faster than ever before. Rapid Plus TCT is where business gets done, and so much more. It's a vibrant landscape of collaborators and groundbreakers, where big ideas are sparked on our show floors, and products are launched into today's most sophisticated applications. With a mission to develop a web of connectivity for key industries, Rapid Plus TCT brings together OEMs, businesses, manufacturing, and people from across the globe to provide solutions in manufacturing like no one else can. Join the innovators and trailblazers of industrial 3D printing. Be part of the solutions to tomorrow's challenges at the only event of its kind, and connect with the people and industries who build the world. Rapid Plus TCT, the solution for additive manufacturing. We pursue new markets and attract new customers. That's why Rapid Plus TCT announced its North American tour, rotating to key geographies to advance and accelerate the adoption of AM. This is a must-attend event. Rapid Plus TCT.
Please welcome Group Director, AM Series SME, Angie Serlong, and Vice President of Programs, SAE International, Chris Chuka.
Good morning and welcome to our last day together here at Rapid Plus TCT, Aerodef Manufacturing, SME Fusion, WCX, and TRX. Lots of events here this week under one roof. I'd like to share a little bit about how SME's commitment to advanced technology like additive manufacturing extends far beyond Rapid Plus TCT. For example, did you know that SME Prime, which stands for Partnership Response in Manufacturing Education, is one of the signature programs of our Education Foundation? Through SME Prime, the foundation partners with private industry, with academia, to build custom manufacturing programs in high schools nationwide. Over 60 schools in 23 states now include AM as part of their core curriculum. You may have seen students walking around here throughout the week, another example of SME's commitment to building the future workforce. Combined with these efforts, and after a couple of fantastic days here with us, I hope you're excited as I am about the future of additive manufacturing. A highlight of this week for me was certainly last night, connecting with people and partners. SMEs partnered with communities like SAE, reinforcing why SME is with like-minded organizations to drive the industry forward. That's why I'm here today with Chris Chuka, Vice President of Programs at SAE International. Chris?
Thank you, Angie. It's wonderful to be sharing this stage with you today and having the opportunity to co-locate WCX 2025, Rapid Plus TCT, AeroDef, and of course TRX. I deeply believe that the partnerships like these we've experienced this week will help industry, government, and academia get to the next level of collaborative growth. At our core, SAE is a standards development organization. We advance knowledge solutions for the benefit of humanity to drive trust, safety, and efficiency across all levels of mobility. This week at WCX, we explored topics like electrification, automated and assisted driving features, software-defined vehicles, and of course, advanced materials in AM. SAE will always take a leadership role in these topics. However, when it makes sense to partner with organizations like SME or America Makes, we have the responsibility to not go it alone. We're leaning into collaborative partnerships, as Angie said, so that we're not frustrating industry of having too many different offerings or competing offerings that simply don't make sense for any of us. SAE has had an active presence at Rapid Plus TCT for many years. Industry knows SAE material specifications for aerospace. This has provided the foundation for SAE consortia activities and qualifications programs like the SAE PRI Group's NADCAP. SAE is getting to a mature space in the continuum of offerings for aerospace with many standards already in use across the industry-led NADCAP program and activities collaboratively to advance. However, we're still facing challenges across the automotive sector. That's why we're all here today in collaboration with WCX. There's still a lot of views out there that additive can't work in automotive for many reasons, but we're trying to solve for that inaccuracy. And this partnership is helping us to pave that path together. I'd like to personally thank SME and America Makes. I'm excited to be a part of the growth of this relationship into the future. Thanks, everyone.
Please welcome to the stage today's Executive Perspective panel, Todd Grimm, President, TA Grimm and Associates, Jeff DeGrange, Chief Commercial Officer of Impossible Objects Incorporated, Rajeev Kulkarni, Chief Strategy Officer of Axtra 3D.
Morning.
Alex Moñino, Senior Vice President and General Manager at HP. And Nils Niemeyer, General Manager at DMG Mori.
Please, a round of applause for my panelists. No, you can sit down. You can sit down. I'm going to sit. That's to encourage them to open up and be warm and all that. If they do a good job, I'll ask you to applaud at the end also. So, gentlemen, I want to start with open-ended question, kind of the elephant in the room. It's state of additive manufacturing. What's your assessment of what's going on in the industry right now, and what got us here, and I'll give you a little bit of information from Tuesday. Asked the very same question. Some said that there's too much doom and gloom, but yet we are in turmoil. Others said they're optimistic. So if you could just quickly give us your assessment of where the industry is or what's going on, and then the fundamental factors that are contributing to that. Please, who would like to start?
Jeff, you want to go?
Yeah, so from my perspective, I think that with a lot of patents expiring, there's been a number of new companies coming into the industry, and so it's really been hyped up. I think it's self-correcting as we're going forward. And one of the things there is for smaller to mid-sized companies out there, there's a lot of technologies that's kind of exploded in the last 10 years in the additive industry. And for the small to mid-sized organizations, they're trying to figure out which one's right for me. So that's my 2 cents.
I'll just say that, we've seen multiple ups and downs in this industry. I think the last 6 months have been the best for this industry, I feel. They've been very positive in the sense that they've really induced a reset in focus on where we need to really focus our attention and what needs to happen for this industry to succeed. If you look at the last 10 years, I think the focus was more on technology, innovation, scale at all costs, growth, funding. And I think the reset that's happening is really bringing back the focus on value benefits, really focus on business models, profitability of the company, and how do you make companies truly sustainable in the space. And I think it was a necessary reset that needs to happen, and I'm glad it's happening at this point.
Rajeev, did I hear correctly? You said like in the last 6 months you're really encouraged by seeing. Did I hear that time frame of 6 months?
Yes.
And before that, well, do you think there was a tipping point where like 6 months ago everyone went from innovation and I got the cool stuff to this more practical business model application focus?
Yeah, I think from 2015 to like the beginning of 2024 was a phase that was very different from 3D System. You saw a big influx of companies coming in. It was a big influx of technology and innovation with less focus on application solutions. What is the customer really wanting? And we all know that you don't take a 3D printer and replace something traditional and everything works. It's an entire workflow that needs to be replaced. And the focus was so much on technology and just what the capabilities of a printer were that we truly lost on what the customer really wanted and how do you replace workflows. Jeff and I have been doing this for a really long time and focused on really putting solutions into customer sites. And I think that focus is coming back. That focus is coming back because applications have become the forefront now. Solutions are becoming the forefront. And I think OEMs are beginning to listening to what the customers really want, I think.
I'm not taking the question off the table. I'm not letting you off the hook, but I do want to comment. It's good to hear what you both just said, because honestly, if you read the headlines and see this company is closed, this company's been acquired, this company has layoffs, it can be rather gloomy. You walk away with the impression that, are we in a death spiral or something else? So the optimism is something that I like hearing right now. So thank you for bringing me up out of the doom and gloom. Alex, did you have?
Sure. So obviously the hype, I would say it's over, but I would not say the consequences of the hype, we've seen all the ripple effect. So I think over the next few months, and I think we'll see that still unfolding. If you see, I think by definition, this industry will be more fragmented than others. I think the fragmentation that we see, given the industry size, et cetera, I think we haven't seen everything unfolding. And I think that will continue mining the confidence of some of the end users, right? Is this going to be around, et cetera? So I think I totally concur with my colleagues on we need to focus on things that solve problems for customers, right? And that's not typically the great announcement on technology that's going to solve everything. That's segment by segment, application by applications, what is right, and then build on use cases of other customers that have had success there. So we give confidence that taking this technology over actually has benefits A, B, C for the end user, not only on that particular part, but then I think it's something as an industry we need to take, what is the benefits on their overall business process, right? And sometimes the customers need to change the metrics in terms of how they measure that. Going to the optimism, I think, again, the hype consequences are not all over, and we'll see it unfold. But having said that, I'm very optimistic on the future of this industry. We're seeing more traction over the last 6 months that we saw probably over the previous 18. And I think that's just going to build up. Again, with what's going on the world right now, I think we as an industry, we can talk and can take advantage of some of that as well. So.
I want to go all the way back to one of your early statements. Did I hear you correctly that we're still too fragmented, too many players in the industry, so we should expect to see more contraction? Did I hear you correctly on that?
Yeah.
Okay.
I believe that's going to be the case. It's just, it's just obvious when you walk the floors, and this, I would say, it's very more contained floor, but when you go to other events, et cetera, it's still, for the size in the industry, just too fragmented.
Too fragmented, which is a good thing. So what I'm interpreting that is if you read in the news that 10 more companies fail or go away in the coming months, that's a good thing. It's not a sign of
I wouldn't take that the whole industry continues going down. I think it's just a natural effect. That's why I'm saying it's not done. I think to stabilize the industry and go back again, I think we need to go through that cycle as an industry.
Your head is shaking.
Yeah, and I'm nodding and I'm agreeing because I think this is also a sign of maturity. The industry is maturing. 5 years, 10 years ago, there was a lot of euphoria about additive manufacturing in general, and that comes with risk-taking, that comes with trying new applications, and also on the vendor side, trying new business models and trying new equipment. What we're seeing more recently is that, and that is a sign of maturity, is that users have more awareness about what works and what might not work. And just naturally, then you're building a certain caution around how you evaluate the options that are out there, which applications you apply, and which applications become successful. So while it might feel like a little bit of a slowing, I think it's actually a good sign that we're moving to that next stage as an industry where we have a better understanding of the technologies that are out there, and we have a better understanding of how they can contribute to our success and how we can utilize them better.
You know, early days, we were definitely fully responsible for the hype. I mean, intentional. I remember an ad by a company in 1990 advertising overnight prototypes, and at the time, nothing could be done in less than 3 to 4 days. But was the hype the last 5 years, do you believe the hype was more of a result of having so many people come into the industry with dreams of grandeur and making riches that now we have so many bodies in there, so now we got that fragmentation and just really wide, that you almost had to hype things up to be heard?
Well, can I take it?
Yeah, please.
Yeah, I mean, so here's my thought on that. Is if you look at how 3D printing is, or additive manufacturing is implemented in any industrial setting, you truly have to go and change the entire workflow. It is not just about replacing a piece of technology and things change. Now, when all the money and the funding came into the industry, the focus was only on one aspect of that workflow, which was the 3D printer itself. And what that led to was expectations on growth rates and scale-ups that were just not sustainable. If you've looked at all the successful applications in our industry, it takes years to really churn out and grind out an application. Look at jewelry, hearing aids, aligners, implants. It's taken decades before these things became big. So the expectations that something would really churn in a couple of years and it'd be very successful and it would scale up and just penetrate traditional manufacturing, those expectations I feel were incorrect. And all the funding and the money that came in with that expectation. What I think the industry and the market is realizing now is the reality of the fact that it's a workflow, it's a cultural change, it's a design change. It's not just a technology change that needs to happen.
Jeff, did you want to say? It looked like you're about ready to say something.
Yeah, I was just going to say that, you know, there's been a lot of new additive companies come into this industry over the years. And basically, in my company I'm with, we're dealing with the investment community. And so you have to put a story that's realistic and honest, but I think that, and again, this is just my perspective, that you were basically selling a story to the investment community that had the wrong timeline to it.
Yeah.
That, you know, can it be achieved? Likely. And, you know, when you do hardware and materials, boy, those are really hard products to bring to market, and more importantly, apply them to products to companies large and small to make those companies money. That takes a lot of time. And in the investment community, they want their investment back, as, depending on what levels of investment that you're talking to, in multiples, in short periods of time. And hardware is hard, is all I'm going to say.
Yeah. No, I think I totally concur. I think that's the key, the timing expectations. I mean, I think we are all believers, and that's why we're in this industry, that eventually this is going to pop and this is going to scale because it just makes sense, right? It's just because all the workflows, it's not changing just one thing. It's a whole business process that they need to change. It's going to take time. And I think investors came with an expectation of time that it just didn't happen, right? And that's, I think, where we're here. But I think the fundamentals still remain on the industry. If you think it just makes sense, and if you fast forward, you know, a decade or 15 years from now, it's just going to happen, right? It's just a matter of when and how you cross that.
And the companies that will stay behind now will be really good customer-focused companies, I think.
Right.
Yeah. So.
And it's true because we're on a physical goods industry. The scalability is different than if you're in a pure digital, right? And it's just, that's why that time takes longer.
You've got a smirk on your face, Nils. What are you thinking? There's something behind that.
So Jeff mentions multiples and working with investment banking, and they apply models to look at the growth of the companies that are most familiar with. When you go into the metal additive manufacturing space, for example, now you're in a deep hardware space, you're in a deep tech space. And if you look at innovation cycles there, they take multiple years.
Yeah.
It already takes a long time to design a new component. Then it takes time to build that component and to inspect it, test it in production or test it in use, and declare it a success. So that whole innovation cycle of introducing additive manufacturing can take somewhere from 1 or 2 years all the way up to 4 years or 5 years. And I think that is a reality that some of the investors are not necessarily used to if they are not in that space. And so we got to be a little bit patient and acknowledge that introducing innovation in this space just takes time. And we need time to prove out that it does work and that it adds value to the economy.
I'm going to ask a follow-up question, but there's nothing on my tablet here. So we want to hear your questions. So open up the SME Plus app. On the home screen at the bottom, there's a tile that says Live Interactions. Click on that, and you can type in a question that'll be ported to this device, and I can pose it to our panelists. And now I just lost my train of thought based on what you said. Oh, so talking about time. So that's looking at the supply side of the equation, the elements of the workflow. Is there a time component that people should appreciate when they're on the consumption side? So bottom line, how does that, it takes time to get like a new piece of hardware out there, apply to the individual in the audience, assuming that they are going to be making the parts?
I'll give you a specific example. So at DMG Mori now makes the drawbars that go into a spindle for the machine tools. So it's a mission-critical component, similar to an engine on the plane. If the engine on the plane is not running, the plane is not flying. If the spindle on the machine tool is not working, the machine is down. The drawbar inside of the spindle requires to have high rigidity, and it requires a hardened surface to have a long lifetime. And originally, this part is made in multiple steps, including roughing, fine machining, grinding, chrome plating. So you have multiple steps that are involved to make this part. It's a prime example for a success story for additive, because now we can utilize DED hybrid machines, so basically a machining center with a DED nozzle that can build up and finish machine the part. You get the same identical part that previously required an 11-day lead time. You get the same part in 2 hours and one setup, one machine, one operator. So the advantage is huge, but I want to get back to the timeline. Why is this not obvious? Why have we not been doing this for a long time? Even though the technology is available, what ultimately enabled this was a personal change in the organization. Somebody who was previously developing additive machines moved into the spindle development department and carried the knowledge along, carried the experience along. And when he saw the drawbars, said immediately, oh, you know what? We can really simplify this, and we can possibly make a better part in shorter time with better cost. And so those factors, they play in as well. We need to find those success stories, but it requires somebody to scout them and to see them and to be knowledgeable and unlock the potential.
Yeah, I fully agree. It's knowledge, and it's also some risk-taking. I was discussing with one of our partners yesterday that they saw in Europe an application that just made a lot of sense for replacement of turbines or something that were 30 years old, and they were basically injection molding it. And in Europe, they've 3D printing it now. But when they come to US, basically that knowledge and the risk is not happening. So we had a discussion how you basically bridge that and how you demonstrate to some colleagues that could be across a different region or just within the same industry in the same region that taking the risk actually paid off, right? And I think we as an industry, obviously that the knowledge is a barrier, right? But the inertia and risk management, it's definitely a barrier for adoption, right? Because people just tend to take whatever works within the overall project to minimize the risks. So.
Yeah, it is.
So,
Now, Jeff, he's got a background in additive as on the user side, working at Boeing and driving technology innovation and applying additive, and then moving into the supply side with Stratasys and now Impossible Objects. So whatever you're going to say, can you also connect the dots on what a user could take away from that and how to facilitate that idea exchange and sparking innovation within your organization?
So
answer that first or second, whatever you want.
So I was going to say that once you actually have done your first article testing and analysis from an engineering perspective, and you're going to move forward with an additive technologies, it's much bigger than that from my life experience. Your design community needs to understand the design freedoms that you have and the do's and don'ts of design principles around given technologies, how to set out your build layouts for the machine. Then once it goes over to your manufacturing community, particularly if it's a new technology, particularly like a company that I'm with now, there's whole workforce development. You might have one or two key technicians or engineers that really understands that, but when they go on vacation or get sick, you're dead in the water in some of the cases until they come back on. So workforce development and understanding the do's and the don'ts of the process from the design side and then from the build side. And then from a QA side, how are you going to QA these parts? We've got a lot of wonderful metrologies out there, and you can get so much information from these metrology QA reports that you might be rejecting parts that you shouldn't be rejecting in some cases because it's given you, maybe it's not a feature or tolerance that you really should be paying attention to. That's up to the design community. And then when you go out to the user is going to say, hey, is this process? So it's peeling the onion back. Design, build, workforce development, QA principles. And then when you go really into mass production with any of our technologies out there, certainly for many large companies and government agencies, they want to see, they don't want to see sole sources. They want to see this being kind of a robust in the supply chain and being able to know that when they push their POs for those multi-year contracts out to those companies, that they can deliver those repeatable results on a monthly basis to cost, to schedule, and quality.
Yeah, even in that, just adopting 3D printing, Todd, I think, if you take an engineer and just show them 3D printing, somebody who's not used it, there are clear technical value propositions, weight reduction, assembly consolidation, conformal cooling, design for functionality, but then there are business value propositions, right? There's mass customization, reduction of inventory, you can just go on and on. The challenge that I've seen, having worked on many applications, is if you get the technology inside a company and you have so many value propositions, sometimes they don't know where to focus, where to start, because not all applications can benefit from all these value propositions, right? You have to match the value proposition to the specific application that is at hand. So our recommendation always has been start with the easiest application that you can start with, match one or two value propositions to that application, get it going, get it running, and start a slow cultural change within the company, and then expand into other applications. But it's a time-consuming process. It takes years to sort of get to a point where you're totally harnessing all the value that this technology and this solution brings in.
Well, let me.
And I would add to that also, when you want to introduce additive manufacturing, there is a difference whether you are introducing a new product or whether you are trying to replace an incumbent technology. In order to replace an incumbent technology, you will see some resistance, right? Why would I use an alternative if this is already working on my application today? Whereas when you introduce a new component or you introduce a new application, it's much easier to look at all the technologies that are out there and consider additive a real option, and basically choose that for your manufacturing process.
I think also, we're talking about the engineer. I think the sponsorship, many times the benefit of using a 3D part, it's not seen within the scope of the engineer.
Right.
Right. It has an impact on the business process because I don't know. It's a spare. The spare parts are much easier or whatever. Right. It can have an impact on the project. So I think getting some sponsorship within the company, right? I think having a change agent at the engineering level, but then having a sponsorship at the management that can have visibility of what that end-to-end process benefit is, and then can potentially even change the metrics within his team. I think that's a great catalyst as well for adoption.
And one more thing to that regard, what we found is sometimes external factors can help too. I mentioned the example that you can replace chrome plating with DED. And when you now go to companies and into the industry and you suggest that solution, it might not be immediately adopted. But what we saw, what helped push this really into the market was when chrome plating is now on the agenda, that it's hazardous and it's a safety concern. So now you have external factors that make you want to replace this conventional process. And so sometimes these external factors, they can actually help you internally convince people much faster and much stronger.
Please.
So I was going to say that I think part of this optimism and acceleration of adopting additive manufacturing is going to be aided by some of the younger generations coming into the industry. So I found throughout my career that when you're bringing a new material and process online, I suspect many of you in the audience are engineers. Engineers by nature are risk averse. And being a former Missourian, when we were looking at new materials and processes, we would say, show me the data, because you have to check the technical boxes to make all the engineering communities feel comfortable that this is a right move. And then you have your business case aspects of it, check the boxes. So the more data you have to kind of burn down those risk questions with your communities, the faster that adoption cycle is going to go from my experience.
Yeah,
So I'm hearing one piece of advice for everyone out there is make sure you don't have an isolated additive manufacturing team. Make sure they're embedded, reaching out, doing outreach and all that, because you're going to be isolated, locked down, and people aren't even going to think about.
Yeah, it's always cross-functional, absolutely.
What's that?
It's always cross-functional to make it successful. Because, you could easily look at a component and say, it cost me so much traditionally, and it cost me so much with additive. But that is not the only cost to compare, right? You really have to compare the cost of the efficiency, the design change, and that leads to a whole bunch of cost analysis that has to be done. And if you look at the total cost of the solution, in most cases, additive wins, actually. But it just requires change points across the entire chain and not just in one place.
And I think every company, if you do an engineering change order, there's a real cost to an engineering change order. How many engineering change orders do you do throughout the life of your product? And is that calculated into your business case?
I want to go to a couple of audience questions, not on topic where we are now, but back to what you were talking about, the fear of single sourcing. That was as someone like a Boeing, single sourcing to somebody for contract manufacturing. This question turns it around. So the question from the audience, it explicitly states concerns from a customer. This is going back to business failures, acquisitions, and the industry consolidating some. Concerns from the customer. The risk is that will the company and support exist on the equipment with consideration of obsolescence, mergers, and or everything else? So basically, I've invested, I've built it out, I know what it is, I'm using it, you disappear. So the question is, how do you or others, OEMs, plan to address this? How do you take away the fear?
I don't know, I'll talk from my experience. Whenever we release something, everything we guarantee, a time period after if we discontinue a lineup that is, up to 7 years where we guarantee support, et cetera. And actually, we build that in our financials, we build that, we plan for that, and that's basically part of our DNA and the value proposition that we propose. I understand there is some startups, smaller companies that basically they might not be able to do that, and that's why I'm saying that I think eventually the ripple effects of the hype, going down are not yet over, and I understand the fear, depending on, if you take the risk that we were discussing, right, from an engineering perspective, on a part that basically you can follow on that risk. So I understand it. I can just, from an HP perspective, how we see that and how we react to that.
Yeah.
So we've got two big established companies, HP and DMG Mori. I'm glad you spoke up because now we've got two companies that you're not startups, but you are early in your
early stage
future.
Yeah. So I'll say something. So I spent 30 years at 3D Systems, one of the largest company in this area, right? Exact same policy as HP's. We will support the equipment at 3D Systems for 5-7 years, and you will have continued support. Now I'm part of 4 startups. Not startups, but companies that are much smaller than what 3D Systems was. Personally, I'm implementing the same rule in all of these to make sure that there is sustained support for the next 5 to 7 years for every product we sell. And again, I'll sort of say this, is when you are evaluating smaller companies, make sure that the focus of that company is on application solution and not just trying to sell you a printer. See if they have business development people who can do consultative exercises with you. Make sure there are some NRE capabilities that the company can engage with you. So it's a partnership more than a supplier and sort of vendor relationship. And those smaller companies that are willing to do that and are doing that are more likely to sustain the longer term in this industry than just companies selling printers and sort of staying aloof from what you're actually doing. And I mean, that would be my sort of only advice to customers who are looking at smaller companies, I think.
Similar thoughts, something different?
So on the whole, typically we like to sell the latest, greatest machines out there. I mean, that's part of our business model, right? And let's just say that you depreciate it over 7 years, but these machines can have useful lives 10 years and beyond. And if you're a small to mid-sized company, you want to try to, really make money with that piece of equipment. And so my whole thinking on the whole, it's a great question, whoever came from the audience on that, is sustainability. As a small company now, it's just like, okay, we're going to support it from the factory for that 7-year depreciation life, but after 7 years, we can do one of two things. We can either A, have value-added resellers out there that we teach them how to maintain those equipment, right, particularly if you're in different parts of the world, and give them the know-how and the knowledge to maintain the machines in their customers' regions. Or B, there's companies here at Rapid this week and at AMUG last week that basically for the machines that have been obsoleted from OEMs, you can work out the appropriate business agreements with those folks, and they can be the ones that keep your machines running beyond the depreciation life.
Now I'm going to offer one from Tuesday and just get a, yeah, that'll work, or no, that's not going to work. So we were in a conversation about the age of inflated financials to try to get the money from the VCs, the investment community, and the numbers just didn't make sense. It was a different conversation, but the point was made that you as a potential buyer of that solution, investing in that solution, should demand under NDA or similar to see the financials of the company. Do you think that's realistic for them to say, you'd obviously have to be making a significant enough investment. It's not a $5,000 printer you're going to demand to see the financials. But if you're staking everything on it, you're going to embed it into your production, it's going to be what your business is about. Is it a viable thing to do? If somebody came to HP, let's look at it from the big company and the smaller companies. If somebody came to Impossible Objects and said, prove to me that you've got this financial stability to keep going on, And if they did the same thing to DMG Mori, would you be open to those kind of conversations?
Want me?
Well, either you're.
With an OEM, with a public OEM, you actually have that transparency and that visibility, right? If you're working with a publicly listed company, you have a possibility to look into the financials. Now, it's working with an OEM. It's easy to say that. I don't think many customers actually do that, but in the sales process, what you're doing, you're vetting your partner. So aside from the financials, you're vetting the partner you're working with. Because ultimately the support goes beyond the financial stability of the company. Of course, the financial stability secures spare parts, secures legacy and continuity of the machines and the support network in the future. But I think it even goes beyond the financials, and it's about how your partner works with you, how they are set up to support you, and it's ultimately about building a relationship and building that trust as well. And make sure that that is part of your evaluation process. Just as much as you're evaluating the application and the technology, you're also evaluating the company you're choosing to work with. And there are signs that show you, yeah, they will be able to support you in the long run.
I fully agree, and I think financials is not everything. I could think on a scenarios that you present pretty financials, and you're just not investing in the spare parts that are required, so you're making your financials better, and just the opposite. So I think financials is part of that. I think it will be tough to, I think I appreciate the question for debate, but I would say it would be tough for companies, for bigger companies, or to share financials beyond maybe what is public. But I totally concur with him that I think it's beyond that. It's more of a partnership, what you discuss, right? Just evaluating the partnership, and there is some signals that can give you, some hints without seeing the financials, but then there is many other things beyond that. And I think typically you also, when you do a purchase, you interact with your sales rep, make sure that, there is an ecosystem beyond just that person, right? And try to get also some references from other people, and at the end it's a risk call.
Yeah, actually, all excellent points. I completely agree. So I'll give you a perspective for smaller company. We are Axtra 3D, we are less than $10 million in revenue. We've been in business for 4 years, so not like an HP or a DMG Mori. We will gladly share financials with you if that is what requires you to form a strong bond with us and a partnership with us. We also have 2 other things we do. We call each of our customer once every 2 weeks. And the way, I'm speaking for Axtra because I manage that company. So after every X machines of sales, we hire a service person just to do exactly that. We call every customer every 2 weeks and engage with them. And I think that's important because I've just seen the other side, and things go haywire when the customer is not supported. The other thing we do is we've empowered our team to make decisions on 4 points. And in the order of priority, number 1 is reliability of the product. Number 2 is customer service. Number 3 is revenue, and number 4 is profit. And we let them make key decisions for the company as long as this order is followed. And we've been selling machines 2 years, and it's been a great relationship. I completely agree with Alex. Make sure there is engagement from the other side. Make sure there is business development activity. Make sure they're willing to work with you. Make sure they're willing to customize certain aspect of the solution with you. If you see those signs, you know that the company is really working in your interest, and it'll stay along for a long time, I think.
I got to interrupt real quick. Unprofessional of me, I closed the app that had all the questions, and I don't know what the name of the app was. So, Alba, in the back. Alba, I'm going to ask you to come to stage right, please. Alba, do you hear me? Stage right, please. So, anyway, continue.
So, also being a small tech company, we would share those financials, but in order to give reassurances to that company that made that major investment into a product that they plan to use for the next 7 to 10 years, we would also probably construct a legal document in the event that we became insolvent, that they would have the right to all the engineering information and software programs that to give them kind of that assurances. And then beyond that, I've certainly been in this industry for decades that, here's some companies, if that worst case scenario occurred, that could be companies that could kind of pick up the ball and run with it.
It's definitely a threat, though. I mean, you can't avoid it entirely. We've seen companies that were acquired with good intention, then the company realizes that, it's not the investment we thought. They let it die off, and your technology platform disappears.
It's a general question, right? Because it even goes beyond 3D printing. If somebody's buying equipment from some other industry and it's a smaller company, the same question still exists, I think.
Financially related, so from the audience, they're asking specifically about VC funding. I want to expand that to any investment funding or from the investment community. So is that funding helping or hurting the industry? I don't quite understand the back end of the question. Need realistic and long-term expectations. I'm guessing that that's kind of back to inflated numbers and expecting bigger returns quickly. So let's just keep the first part of the question. Is investment funding or VC funding helping or hurting the industry?
I think if it's with the right expectations, it's helping. If it's with accelerated and realistic expectations, then I think we would get into another hype. So that's what I would say. I think as any business, you need to be careful, what even you get offered, and make sure that you can deliver, right? Because eventually it catches, it goes back to you, right? You can take money, but if you don't feel you can deliver, that eventually is going to catch up with you. So, if for people that we are here in the companies or in the industry for the long run, you need to make sure that when you're given money and investment, you feel you have the setup for success. And obviously there is a risk component as any venture, right? That's what innovation is about, what technology development is about. It's not about 150% safety, otherwise, we would never advance.
If I can just comment real quick. I've always felt that overexuberance from the investment community pumped too much money into additive and gave birth and life to companies that really shouldn't have been given birth or life. That created all this fragmentation and this expansive supply base of additive solutions. But now that they've once burned, twice shy, now that they've been burned, I'm hearing that the money's it's harder to come by, True. Which is forcing some of our contraction right now because those companies are no longer fueled, the new companies aren't coming in, but the beneficial outcome is that we are getting less and less fragmented, as you said, Alex. Jeff, were you going to say? Oh.
Yeah, I'm just going to say from a small company, we deal with the investment community, and I would say it's slowed significantly the last couple years for the reasons that's been stated up here. And I will also say it's kind of both sides of the coin. It's helped, and it's also hurt, and whether you're a small tech company like Impossible Objects or other small tech companies like us, the investment community has seen what has happened in additive the last couple years and the major investments in these crazy evaluations out there. And they're looking to other types of investments outside of additive. And so do I think it'll come back? Yes, but it's slowed.
Okay. I would just answer that in a different way is, all the money that came in, I felt it looked at addressable markets and growth rates. And the addressable markets for 3D printing are so huge, they're in the billions, that they're almost meaningless in my view because what is a 2 billion market and a 10 billion market? It's almost the same. And if you are a $2 million, $5 million company, it's so big that it doesn't matter really. The other thing was the expected growth rate that came in with that money. That was unrealistic. I think what perhaps the community, the investment community should have done better is look at the penetration rates of our technology and our solutions. Because like I said before, you have to replace an entire workflow in a company to get 3D printing or AM into it. And that process is slow. So if you really evaluate a company based on penetration rates that it can achieve in getting their technology and solutions into other companies, that would be a better metric to look at when you fund a company rather than looking at just addressable markets. So that would be my point on that, actually.
And I would say probably a mix in the industry is helpful. you have to look at what are the alternatives, right? VC funding is one vehicle. The other vehicle is maybe a loan or financing your R&D through revenues. So that's actually what most of the OEMs will be doing. They will be funding their R&D through the revenues they are generating. What that does, introduces a different discipline in the R&D development. Because now when you have 5 great ideas, you cannot chase after all of them. You really have to choose. You have to pick and choose which ideas you can develop all the way through the end. So that is good for a more gradual and more sustainable development of ideas. But at the same time, if you want these great and disruptive ideas, VC funding can often help us chase ideas that otherwise in a more conservative or more disciplined environment would have never been introduced. And so I think a mix is reasonable. And we've seen VC funding stronger for the last 5 to 10 years maybe. And currently the cycle is turning a little bit. And we're becoming a little bit more disciplined in what we're developing and what we're chasing.
Excellent. I'm going to shift gears just a little bit. So we've mentioned workflow. Got a two-part, actually 2 questions embedded into one. So the first part is, this is more on the personnel side in having success. Which skill sets do you consider most important for the future of additive? Which skill sets are most important for the future of additive? I'm assuming this is coming from the consumption side, the user side, to make additive work. Is it the design engineer, the mechanical engineer? Is it the QA team to make sure it's all working? Is it machine operation? Is it using advanced technologies? Which skill sets are most important?
I can start. I would say the ability to build a business case and convince your company that there's value to what's coming in. I think the individual who can truly develop that ability to convince multiple departments, sub-organizations within a larger organization to truly understand the overall value of 3D printing and bring it in, I think that skill set has the most value because it comes with various components. And I've seen every time having a champion like that inside a company is where adoption happens quite seamlessly and there is true value harnessed out of the solution.
I'm glad you said the word champion because I believe that's still critical.
Yes,
to make
it's critical.
additive
Absolutely.
So
Absolutely.
if you don't have a champion in your organization or if you are not that champion, go find one. And then also make sure you keep them because I'll see if you all agree. If the champion gets additive to ignite and take off in your organization and then leaves and goes to work for someone else, I feel that it still happens, that they disappear and then all your initiatives decrease and you fall back into old habits. So,
and I think what he's bringing, it's an awesome point because at the end, the benefits of 3D printing are not in the part itself. So typically the champion is always an engineer and she or he, beyond the technical ability, needs to develop the influential ability within the organization. And that's not obvious, right? Right. Especially with the engineering community. I'm an engineer, right? I moved to the dark side of business pretty early in my career. But it's not obvious, right? Because many engineers, they never have to develop that within their specialty. Yeah. And the other one would be the be curious in terms of, and we're discussing more soft skills, more than hard skills in order to be influential. And the other one would be curious on the new technologies that are there. That could be, printing or manufacturing technologies themselves, or could be things like, AI trends that help you be more efficient in your design, right? And that's eventually gonna, because some of the hurdles right now is how you redesign a part for 3D, et cetera, how you use new technologies in order to basically shortcut that to a fraction.
And for execution and implementation, a skill set around the design, around the materials, around the operation of the equipment, that is crucial for the execution. But yeah, in the end, it starts with the idea. So somebody that can look at the business case, and with that also comes having an understanding for the whole supply chain. So people that have a more holistic skill set that do not only know additive manufacturing, but also the alternative technologies. Because at the end, in the organization, we have to justify why are we not machining this, why are we not casting this, why are we not using other technologies. And so if you look from the design to the finished product in the end, you'll be able to find the potential in where additive manufacturing fits. But if that champion is only focused on additive manufacturing, it's so easy to lose the big view for the whole supply chain.
So I was just going to say that from a skill step perspective, if you could say, hey, what bucket does that fall into, this champion fall into? I was going to say from my thoughts, one, it's a systems person. They see cradle to grave across the thing. So they got kind of a systems outlook, number one. And two, if you have job functions or job classifications within your company, somebody that's a technology scout. They're looking at the technologies, the materials from a systems perspective.
That's beautiful. Get a lot of work to do if you don't have all that in place. I'm going to switch gears here. Please answer this without embarrassing the person who asked the question. How can you actually 3D print a functional plastic part that doesn't crack along a layer line, i.e. a football helmet? Can it compete with injection molding? The reason I say embarrassing, personally, my view is you haven't been exposed to the breadth of solutions. Maybe the price point is out of your range. Well, Jeff won't do it. Impossible Objects makes carbon fiber parts using carbon fiber cloth impregnated with resin. Jeff, I think you could build a football helmet that could take the impact. But that's not your market. So can we expand this question a little bit in the way, I know the way I want it to go, but I don't want to ask you directly. So can it take the hit? Can it take the hit?
Well, I'll say a little differently. So in my lifetime, I've developed maybe 350 applications, different applications. And one thing I've realized is the applications that truly blend traditional with additive are the most successful ones. It's never really printing the end-use part directly with additive. There are very limited options given the technology where it is and the process reliability where it is. So I'll give an example. For mold inserts or sacrificial patterns, you really get the entire design freedom and mass customization through making patterns and sacrificial patterns. And then you can truly go and use your traditional processes and create parts using your traditional materials. And so think more about blending traditional with additive, more so than let me just print the whole thing with additive and figure out how to replace the whole thing. I think if you create a seamless bridge that way, I think there's more value in our technology than trying to do all of it through additive, I think.
I didn't fully get the question, but maybe, just...
Well, if I can stop you, I'm embarrassed that I put it in that context. I was triggered by the phrase layer lines. To me, that says you're focused solely on an FFF or FDM solution. So I was coming at it from, you've got the blinders on and not expanding your field of view.
And I was going to answer in that sense, just kind of offer the audience. It's not about buying machines. It's about accessing technology, right? And I think, you can access technology different ways. Likely this industry is mature enough that, you have a number of players that offer technology options, so you don't have to buy the equipment, but you can basically outsource, try different technologies without having to make the investment, try it out, make sure that the supplier, contract manufacturer, or service bureau is serious, cares about quality, so you don't have false expectations. Start there, and then if you feel that is the right technology, then you can question or you can make the business case to bring that in-house one way or another. But I think if you have a $5,000 budget, you can either buy a printer or source parts for $5,000 and get better parts. So that's just what I wanted to offer.
So I'm going to say there's different parameter sets you can change on your machines, depending on the process. And so I think it takes some investigation and some trials to do different parameter sets, build orientations. And then another key factor from my perspective, can it take the hit per se? Well, use a lot of the design simulation tools out there, and because there's a lot of internal structure you can do to stiffen on the inside where you would put your foam inserts in. So you've got design freedoms with additive, and so your parameter sets on your build orientation, but then your design based on what type of load impacts you can have. You got a lot of freedom to do that to actually take the hit.
I'm going to stop that. I would love to continue on, but we got a lot of good questions here, and I want to make sure I squeeze them in. I've got two related to education. I'm going to ask both questions back to back. Let's fold in the answer. So our first question is in the context of, as a high school CAD teacher, what improvements do you envision in education for a better prepared future workforce, and how can your company support the schools? So that is improvements for better prepared workforce, and how can you support that? The other question is, from an industry support and sustainability perspective, what skills and knowledge must be imparted to the next gen in the universities and even K-12 spaces? So what education do we need to impart, and what improvements do we need to make in the education system and our support?
First idea that comes to mind, if we compare this, ultimately additive manufacturing is a generative process. It's like a forming or generative process. And we used to have casting, and casting has been around for a long time. So over decades, we have developed industry norms for how to design. Which angles, which chamfers, or which radii does a designer need to consider when they design for casting? Additive manufacturing is newer, so these norms and standardizations, they haven't been around yet. But what we are seeing is that the industry is coming together, and they are defining these norms. And vendors like DMG Mori and others, they have an input there. Because we see firsthand when a build job fails or when it is successful. So I think in the future what we will see in schools is design guidelines being taught similar to what has been taught, for example, for castings or other processes. And as an industry, we're coming together to formulate those norms, and then we'll see those go into the schools in the future.
Other education?
I would say make sure you have maker spaces within your schools and universities for sure. I've helped start 2 or 3 in my neighborhood. It's just phenomenal. It completely opens their eyes. 3D printing, I feel, is such a great STEM tool because you learn physics, mechanical engineering, computer science, material science, design, CAD, all of it comes in one sort of exercise and one sort of activity. And it opens up the kids' minds, it opens up skill sets, it helps them understand what is sort of their expertise if they want to pursue engineering or a STEM field. And I think just start maker spaces wherever you are and encourage kids and students to come to that.
And it's what I would offer right now. I think the world with AI is changing the role of design. Yeah. And I'll just offer, we at HP, we have a gaming platform, right? Where we provide gaming, and one of the services we provide is if you want to print your own character, you can do it, right? Because the gamers are very into it, and that's very related to like kids, etc. So we started the service by basically having a designer spending 3 to 5 hours designing a character, and we had to build that in the price. Now with AI tools, it takes 2.5 minutes,
right?
And you can see that in our booth, and that's just a technology that's pervasive, and I know it's beyond 3D printing, and I think can help, because one of the hurdles from what you're saying is, how do I start a design?
Correct.
The design tools were cumbersome, but now from very small age, they can basically design and buy a $500 printer and get started, right? So
It completely changes their
it changes the game.
perspective. Yeah.
It changes the game and their perspective.
Jeff?
So I was going to say that if you're not familiar with Fab Labs, one of the coolest Fab Labs is in the Chicago Museum of Science and Industry. And they usually bring a lot of at-risk high school students there, and they have different modules that they do there. So they have 20 workstations that they set the high school kids down at, and they teach them some of the basics of designs, and then they send some of those files to sign cutters, so they go home with a sign off of a sign cutter with their name on it. And then another module that they do is they send them to basically extrusion, FFF or FDM machines. And when I was at Stratasys, we basically helped fund some of these initiatives. And I don't know if there's companies still doing it or not, talking from the OEM side. But my thought is that many of these high school students that came into the Fab Lab, they felt like, hey, if you're going to do additive manufacturing 3D printing, you've got to be really smart. I'm not smart. And I'm not smart in math. But the young generations, they're wizards on electronics. You set them down in a tube, start to show it's not so hard, and you do one-on-one class, and then you do another module, you do a 201 class, and you keep kind of raising their knowledge base. And so my thought might be, whoever asked that question, is that there's some great modules that's already been developed by like the Fab Lab community out there. Can we port those modules over to the schools in the country or throughout Europe? And even if you have to tweak them a little bit.
And actually, one important aspect for high schoolers is probably to stir up their curiosity. And NIMS, NIMS, they actually have a series where they introduce certain job functions. So they have short videos where they show, okay, this is what a machinist does, this is what a designer does, what a programmer does. And over the last year or two, we've been working together with NIMS to create a video series also for additive manufacturing. And it's typically 3 to 5 minute videos, so fairly short, but I think that's a way to create awareness and curiosity in high school students also, what this job is about and what it can do for them in the future.
Good stuff, but I do want to move on because we're coming up on the end. That two-part or two questions embedded into one, I want to come back to that because a hot topic. The question is, on a scale of importance, where do you see AI and machine learning? I'd like to expand that into what do you think is real now, where are we going kind of conversation. So AI and the subset machine learning, what are your thoughts?
So maybe I'll start. I think there is two aspects to it as an industry. One is we're going to basically use AI, all companies, to basically make our processes more efficient, ourselves more efficient. So that's something. The machine learning and AI, when you look at the additive processes, there is a lot of data that is generated. So all that data can basically, we have now new tools that can help you process, do quality control. And we at HP, we use a lot of AI within our printing process, quality process. We adjust the parameters based on the heating, etc. So all of that. And then the third area would be everything that is around content generation. And I think we have an opportunity right now, and it's very early on the game, but to use AI to really scale content, 3D content, in a way that haven't done before. From more a consumery type of goods, and you see the car that we have at the booth there that you can design some of the parts with AI, and get those printed. I would put some personalization aspects, make that, in a very scalable way, so you don't have to spend hours making the part non-affordable, designing that part. But basically, so I think that's going to really scale. But I think that eventually will go to the engineering parts, where you fix some critical parameters of the parts that you don't want the AI to change, but then you might want AI to help you in the design of the rest of the part. So those are some of the three thoughts that I would offer.
I feel AI has a huge role to play, but I think it's just beyond 3D printing. So we've always talked about digital manufacturing for a long time, and I think the three main components of digital manufacturing is IoT, which is largely Industry 4.0, which we used to call it. Then there's 3D printing, which is digital manufacturing. But this whole bridge in between, which was the data analysis, that has been missing. And I feel that with IoT and the sensors and all of that, we create loads and loads of data in products and machines and technology. I think AI gives us the first chance to create actionable insights that can be truly used in a closed loop form as the process is going on. And I think that really helps a lot to then, for the 3D printing or even perhaps traditional manufacturing CNC, to use those insights in a real time and actually enable digital manufacturing. So I think all the three components go hand in hand, along with the other benefits like generative design and predictive maintenance and process development, material development. It's all useful there. But essentially, I think if we look at our machines, they're not highly reliable. That's what our sort of image is out there. And I think for the first time with real-time analysis and real-time insights, we can make truly closed-loop systems which will truly improve reliability and predictability of our systems, I think.
I'm going to give you kind of the here and now and then future state from my perspective. I completely agree with what you said there. I think there's some software companies coming out right now, particularly for small to mid-sized companies that don't have these larger engineering groups in them. And you're really taking a serious look at additive to figure out what's the right material and what's the right process for my product based on material requirements, cost, and everything else. And having software tools that can go out there and say, okay, this is the material properties I need, the dimensional tolerances I need, the cost thing, and go out and search this vast world of knowledge and additive and say, here's the two or three technologies you need to take a close look into. I think that would be very helpful and help accelerate and scale further adoption for other types of applications, for other verticals. And then long term, I think that AI, machine learning, AI, we're doing it with vision systems and other types of things that every layer is inspected and making real-time corrections because you want to make sure that build on Monday gives you the same mechanical properties and dimensional properties as the build the following week on Monday. And I think AI has the potential to, with the processing speed and taking all that data and helping get repeatable results.
I'm not going to force you to answer. Matter of fact, we want to end right on time so everybody can get to the show floor. So with the remaining 5-ish minutes that we have, each of you give you an opportunity for a closing statement, something that you feel strongly about that wasn't brought up, or a recap to really drive home what your thoughts are to help the audience. And I'm not even going to pick the order. So who would like to go first with their closing statement? Raj, oh, you're going to go? Good.
No, I was going to let Jeff go.
No, you can't nominate Jeff.
You want to go, Jeff? I go.
Go ahead.
Well, I'll just say this, and I believe this very strongly in our industry is, if you look at your P&L, technology is the cost and application is the revenue. So every decision you make as a user or an OEM, focus on which side of the P&L you are. Are you really truly increasing the cost because you're just developing technology, or are you truly developing solutions and applications so that you can create a business and be profitable? I think have a real focus on that. And the last point I'll make is there are three terms that I think we should eliminate from this industry. One is replacing traditional. It's never going to happen. It's always a complementary technology. There is no inflection point coming, and there is no killer app coming. It is a slow grind. If you want to make something successful, you have to work at it, you have to grind at it, and it will happen, but it's not going to happen overnight. So I'll just leave you with that.
Beautiful.
Maybe two thoughts. One is, addressing it to you, to the audience, be influencers within your company, be change agents. And I think to do that, we've discussed, it's not only about the part, it's about the overall system, about the business processes that you change. And I think that can give you an opportunity also to do that. So I think you need to help, to your company to look broader. And second is, I just want to reiterate my optimism about the industry, which is not about the next hockey stick, but it's about sustained, profitable growth for this industry. This industry just makes sense. Eventually, it's not going to replace traditional, I fully agree, but it's going to become much more relevant than what it is right now. And it's, part by part, use case by use case, that will make it happen.
Yep.
And I think a big focus today and even more in the future is on cost per application or cost per part. As an industry, we are more mature than we were years ago, so we see the quality that can be achieved is sufficient and is good. Now it's about making that quality work for the business, so cost per part is becoming more important. That is not only achieved through new systems or new technology, that is also achieved through utilizing the systems more efficiently. How do I handle the powder? How much time do I need between changeovers? What is the overall lifetime cost of the system? And so we are seeing that the quality of the technology is there, the real use cases are there, and now it's going to be about gradually and sustainably adopting the technology and making it fit into the cost model, into the business model of the organization.
Jeff, you've got the last word.
So I was going to say, whether you're large or a small company, take a holistic look at it. Look at, the design, build, and then making spare parts over the life cycle of that. So be holistic. Look at the big picture. Just don't say, hey, I got to make this design that meet these requirements and give it off to manufacturing. So think big picture. And then the last thing I'm going to say is, you've heard this echoed from all four of us up here. Workforce development, don't overlook that, because it takes, educating your design communities, your build communities, your QA communities on this front. And so just bear that in mind and how you can kind of streamline that and accelerate those types of initiatives.
I agree, yeah.
Beautiful remarks. Beautiful remarks. Now, I'm going to ask, not yet, I'm going to ask for a round of applause, but I want to tell you that we do have a very short presentation as soon as we exit the stage, so please show that presenter some courtesy. Stay in your seats. Don't run off as soon as you applaud. But anyway, I think the conversation was fantastic. The information exchange was very beneficial and powerful. If you also think that's true, please, a round of applause for our panelists.
Thank you.
Please welcome to the stage Group Director, AM Series, Angie Zerlong.
Thank you, Todd, and thank you to all the panelists this morning. But most of all, I want to thank all of you here. SME looks to advance our mission through advanced manufacturing, and we really couldn't do it with all the support of the AM community here. So on behalf of SME and myself, thank you all for a great week here in Detroit. I hope to see you all next year in Boston, April 14th through the 16th. We're really excited about going to a new destination. And lastly, if you're still around this afternoon, we will be closing out the show with an ice cream social in the SME Workforce Critical area. So please join us back there from 2 to 3 today, and have a great day. Again, thank you.
You were such a prophet back in 60.